Hey guys, what's up? R1R0 here. In this video, we will go through another exploit development scenario and as part of OSCE preparation for this alt certification. So before jumping into the scenario, I want to talk about the timeline and the plan for this project. So according to my plan, I'm supposed to create one video per week because approximately I spend like 3 hours on creating, editing, and like right now talking about what I've recorded before to explain the attack. But if you would see my personal plan, you would probably cry for me because it's super busy. I'm doing bug bounty, pen test, and doing exploit development, mainly doing exploit development for OSCE certification. So my plan is like my schedule is super busy because I also have a full-time job. I'm working at HackerOne as a senior solutions architect. So my life is a mess right now. So I'm trying to create these videos for you guys, for community to teach how to prepare for the certification. I realized that I never explained what kind of plan that I'm going to follow because it makes sense when I see your comments or DMs asking, oh, are you on Rosario? You forgot mention about bad characters. You forgot mention about blah, blah. I didn't forget anything. I'm not like this drunk uncle coming sometimes. I just want to do this right now. I will create a video. That's not the plan. I am exactly following how I prepared for OSCE myself. And of course, I have a list that I'm following, all the exploits that I wrote myself. So I'm just showing you at the moment the exploits that I'm following based on my OSCE preparation. There are a couple of apps that I noted in here, but it's not the only thing that I've included. For instance, some scenarios were important when it comes to fuzzing. Some of them are important for different techniques, CEH, alphanumeric encoding, accounting, etc. There are so many more applications. It's not only these. You can also find them in my GitHub repository, but yeah, I will start following a plan like this, like the most basic buffer overflow scenario, stack buffer overflow. I started with the most easy scenario ever with like, there's no bad character finding. It's like super straightforward, finding jump PSP. And then from there, you're just getting whether an exploit or you're popping up a calculator. I started with a very easy scenario, but it doesn't mean that I forgot something. I am just adding new methodologies, new different methods in every single video, and I will increase the difficulty in this way. So that doesn't mean that we will always stay in these easy scenarios, but if I right now create a scenario that I spent writing the exploit for 2 weekends, which will probably take like 2 hours here in YouTube, you would probably get intimidated. That's not something that I want. And exploit development is not something that you can learn in one video, or you're just going to learn one technique and you're done. I'm not done yet. I'm learning every single day, and I will probably learn for a lifetime. And people are still finding 0 days out there. People are finding new techniques out there. It's not something that you can learn completely. Nobody's expert on this. I'm not an expert on this, at least. I'm just trying to show how I prepared for the certification, how I got it, exactly the same plan that I followed. Hopefully it will work for you too. So while you're commenting, please be mindful. It's not like I'm creating an online course for you, or I'm not offering a service or anything. It's actually just me sharing my knowledge. Please be mindful when you're writing comments or DMs. It's just me sharing my knowledge. Okay, if you know me, you would probably understand that I hate to chat, so let's jump into exploitation. Cool. So this will be the Vulnserver. Somebody created this Vulnserver. I don't know who is that genius, but it includes so many different exploitation scenarios. So this will be very helpful for us while we are learning different techniques. I'm going to use one comment included in this one server, which is TRUN. So as you can see, this is my Windows XP SP3 server. This is my IP address. Vulnserver is running, and this is my Kali. I just connected to it via SSH or via PuTTY. I'm just connecting to the Vulnserver on Windows with the IP address of Windows and 9999, the port number. And as you can see, all the comments in here after writing help. And the one that we're going to exploit will be TRUN. Cool. Let's realize what we're going to use in here as tools. We're going to use Immunity Debugger. I'm just running as this administrator. This is ridiculous, like XP/SP3 server. But yeah, bear with me. So we're going to attach the process, which is Vulnserver. If you sort it by the name, it should be at the end. You can also like make the window a bit bigger to see the port number, the full path, etc. But we know what process is running. So we are pressing on the run button. So that the process can continue running. All cool. So the next thing I want to do is I want to fuzz the application to understand what's the offset should be, what kind of number it should include to find the offset. So just pause the video for a second, please. This is a very simple comment from Spike. I'm also attaching the official manual for Spike. This is a tool that we're going to use while doing fuzzing. I will create another video later to just show how to do fuzzing before we go into more deep techniques with using different tools. I will create this video, don't worry guys. But I'm also attaching the official manual here. It's very easy to understand. As you can see, I'm just writing like 3 lines, reading lines, and then string will be the one which is the vulnerable comment here. Then we are putting delimiter, which is space, and then for the variable, I'm just writing test, and it will send all kind of payloads there. Cool. So I also installed the tool Spike to Kali, and I will send this payload with the syntax generic send TCP as a comment, and the IP address of the Windows server, which is hosting the Vulnserver exe file, the port number 999, the file name is trun.sbk, and these are the options that you are learning while you're using Spike. I'm also attaching in here what this means. So when I sent this, as you can see in the second or something, it just crashed. So I'm thinking that probably this 5,000 something should be what we're going to use while we're finding the offset. So I will start writing my exploit here. It's a Python exploit. I just changed my computer, guys, and the keyboard is German now, German keyboard, because I'm living in Germany, but I'm not German. Since I'm learning German, I said that, okay, let's change the keyboard and let's be bold here and get a German keyboard. So as you can see, I'm doing 1 million typos now because the characters are in different places. So bear with me, please. Anyway, we imported these OSCE and socket, and we're writing the IP address of the Windows server with a variable host. You don't have to define it with a variable, but I like defining them. It looks much more clear. I'm defining another variable called buffer. This will include all of our payload. So if you're asking me right now, why am I including these weird characters after TRUN, please pause the video, go to a few seconds before when the crash happened in Immunity Debugger. You will see this was appearing in the memory. I'm just attaching one screenshot here, but you should be able to find this yourself. So this appeared in the memory. That's why this appeared in the memory. That's exactly why I'm including this in my exploit. And after this, I will include whatever payload that I will create, okay? Cool. So since I saw that 5,000 something creates crash, I'm just sending 5005 a character. So after that point, you will see some of the comments that I'm writing for connecting the server and sending the payload that I created here with the variable name buffer. These are totally the comments that you will use probably in every single exploit. So if you don't understand it, try to understand and try to memorize it, because you will use this in every single exploit anyway. But what I'm doing is I'm generally having the skeleton exploits, so I don't need to spend time on writing these one by one. Very easy to understand, but we're going to develop some exploits, so we have to learn some Python, right? I'm firing up Vulnserver again. I'm running Immunity Debugger as administrator. I'm attaching the process in the same way. Please don't ask me to zoom all the time. I'm trying to zoom already. Zoom yourself if you want to see something else that I didn't zoom before. Cool. I'm just adjusting the size a bit, running the file, and I will run my exploit now to see what's going on. All right, let's see what's going on in the registers. As you can see, EX register is filled with TRUN, with these weird characters and so many A characters. Cool. You can also see, you can also follow in dump from the ESP registers to see what's going on in the memory. As you can see, it's filled with A. But this is not the right approach. I want to see what's the exact offset. So what I will do is I will create a unique pattern by using Metasploit Framework's pattern create.rb, a Ruby file. If you don't know where it is, just say locate pattern create. Linux will tell you where the exact path is, and then we will create with the length with -l option 5005 characters. Just a unique pattern. I'll just define another variable so that I can remove it very quickly later. I'm calling it pattern, and I'm pasting that. I think I will do a typo here, or the quotation mark will stay in the next line. Yeah, here. Anyway, I will edit it. Let me speak in the background. This is like a unique pattern. This is like a unique pattern that we are creating here. We will send this to make sure that we can understand what's filled in EIP, and then we will check with another tool from Metasploit Framework to make sure we will find the exact offset. So as you can see, when I send it, EIP is filled with some unique pattern. I'm just going to use this tool from Metasploit Framework, like I said, pattern offset .rb. I'm forgetting right now to write the extension. It's a Ruby file. And we're using the option -q and then the pattern that we saw in EIP register, which will give us the exact offset. Cool, it's 2003, very cool. I'm going back to my exploit to modify it again because there's nothing we can do with this pattern anymore. We know how to manage the EIP register now. So instead of pattern, I will write 2003 A characters. You can write B, C, D, whatever, doesn't matter. But everybody uses A. I think it's like the thing that everybody does. Then I'm sending 4 bytes of B character for EIP register. I have to see 42, 42, 42, 42 in the EIP register. And I'm sending 1000 C character. It should be okay, but because in the beginning we sent like 5000 characters and it didn't create any problem. It just crashed the app properly. So should be fine. I'm restarting the process. I'm sending this again. Vulnserver is running. Very cool. We're going back to PuTTY and sending the exploit again. I'm checking the IP register, which is filled with 4242. And if you dump the ESP to see memory, as you can see, 43 is there. Before that, 4 bytes is filled with 42. And 2003 characters is filled with 41, which is cool. That was the expected behavior. Next thing I will do is I will manage EIP register and will fill it with jump ESP, finding it from the memory. I will use mono for this with the following command, mono find -a for the hex value for jump ESP, which is FFE4. As you can see, these are the values that we find. We will try to choose one with the less protection, especially with ASLR. We don't want it because it will randomize the address then. So I am thinking that the first one should be okay. And later I will write this in my exploit in the little endian form, which means I will start with the last 2 bytes and will write it in the first 2 bytes with \x character and write that address. Oh God, so old, right? So funny. Okay, let's get back to our exploit. So instead of B, I want to write jump ESP address, and I will just define another character called jump. It always helps to write some knobslets after the EIP value. I always do that before including my exploit. I definitely recommend you guys. And then I'm writing my exploit, but I didn't define any of these variables, so I will just continue with the C character for testing purpose as 1000 C character. Oh, cool. For the jump variable, I will be writing the address that I found for the jump ESP in the little endian form, like I said, take the last 2 bytes and then write it with \x and then the address. And in this way, you should have 4 bytes for EIP value. I think I wrote it. I did a typo there. Yep, perfect. That should be cool. The next thing I want to do is I want to decide the bad characters. So I'm always keeping these in one place so that I can copy paste very easily. I just included them all in here, and after EIP register value, which is jump PSP, I included these bad characters. So never start with 00 because 00 is always bad character for everything. Just send it like that, and then check ESP value and follow and dump, and from there compare the values. It should go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 0A, 0B, etc. So just check which value is corrupted, then that value will be the bad character, and we will note this down, and we will modify our exploit by removing this value from bad character list so that we can continue checking for the next bad character. But in here, there's no bad character besides the default one, which is 00, but still the technique will be the same for every single exploit that we write. I'm comparing it with the original value. I think it would help to show it in 16 bytes. So I'm saying hex and saying 16 bytes. As you can see, the values are exactly as it's supposed to be, and it's going until FF. Very cool, then that means only 00 is the bad character. Now I am writing my exploit with MSF Venom. MSF Venom -P for payload, then Windows shell reverse TCP, the payload that we are always including. Lhost will be my own IP address, but I should verify it. I'm not sure the Cali's IP address. I forgot these very quickly. Yeah, 173, L port, whatever the port that you're going to listen on. The platform will be Windows. The architecture will be x86. Encryption will be Shikaraganai. You can also use another one. I like using this one. In the next videos, we will use different encryption methods also. For bad characters, I'm defining 00. -F will be fighting. We'll be writing it in a fighting code, and V will be the variable that I'm defining, which is shellcode. Cool, I will copy and paste this in my exploit. Let's remove the bad character. We don't want it anymore. We tested it already. Let's remove that and write our shellcode. I don't know why I've defined it in here. It's already going to come with the MSF Venom output. Sometimes we all get confused, right? Okay, let's remove this first shellcode variable. I have no idea why I defined it. Need more coffee, more caffeine, please. Thank you. Let's remove that. Cool. Let's modify the buffer variable a bit. TRUN, these characters, then 2003A, which is offset, jump PSP value, nopsleds, and our exploit to get a reverse shell. I'm writing it in Kali, as you can see, because Putty created some errors with copy and paste, so it's always easy to do it in here. I will start listening on the port 8888, but I wanted to just read the file with cat a bit to make sure you understand what's going on. Just feel free to pause the video if you are stuck with some point. So start listening on port 8888 as we define with MSF Venom, because people get the reverse shell here. I will go back to my Windows server for one more time. I will run this exploit. I'm restarting the process, sending it again. Vulnserver is running properly. I'm going back to my Putty, just sending the exploit very quickly. As you can see, it didn't crash, but here we got our reverse shell. Very easy, very quick. All right, hope you enjoyed this video. Like I said, we are going through a plan. If you're asking me how many videos there will be at least 20 to 30 videos. I'm 100% sure about this because I think I included more than 30 exploits in my OSCE preparation. You can just check my GitHub repository. I included almost all of them there. So I will try to go through each of them in these videos, but some of the exploits are so cool, so beautiful, believe me. And there are so many techniques to write them. They're not only like one technique to write the exploit. So I will try to include as many of them possible. And some of them are really hard. I remember I was spending like multiple weekends on some of the exploits and my brain was burning. And right now for OSCE preparation, it is beyond OSCE. The topics are totally much more harder. So in the parallel, I'm only for myself working for OSCE. So hopefully when I finish creating the videos for OSCE, everything will be easy in my mind for OSCE so that I can start creating videos for OSCE too. And I'm thinking, what would happen when I'm getting my OSCE if I watch these videos? I'm sure that it would help a lot. Hopefully these are also helping you, whether you're getting a certification or you just want to learn exploit development to satisfy yourself. Welcome to this beautiful world of binary exploitation. I'll see you next week, guys. Cheers.